Appreciate the invitation. I'm going to share a pretty unique data set that we've collected at Simplot Livestock, and also share some information about a tool that we've created for congestive heart failure that's commercially available today. Before I get too far into that, just wanted to put this up here. The past couple of days and in the past, we keep getting asked, are PAP and congestive heart failure the same trait? That question keeps coming up over and over again. We think the answer is probably not. Dr. Holt and the other presenters have done a great job of describing PAP, the factors that lead to PAP, and how that genetic cascade kind of kicks off and an animal ends up in congestive heart failure. That's one pathway. Kind of drew this dotted line up here on purpose. That's one pathway how we get to congestive heart failure. But there's other factors as well that bring this trait to the light. Obesity. Talk about weather patterns. In our part of the world, we certainly have hot summers that drive this trait. We certainly see an uptick in congestive heart failure when it gets warm in Grandview, Idaho. And under both of these traits, we have the genetic component. So there's a genetic component for PAP, genetic component for congestive heart failure. We know the genetic correlation between them is probably not one. So that indicates there's an independent set of genes leading to congestive heart failure. There's an independent set of genes leading to PAP. But there's also some crossover. These two traits are related. It's pretty clear from the physiology how that works. At the end of the day, this is what we're trying to prevent. This is two heart score 4s or 5s that we pulled out of our feedlot in Grandview in August of 2021. These were fat, pretty animals that were ready to get on a truck, and they didn't make it to the truck. And this is what we're ultimately trying to prevent. There was a lot of cost sunk into those animals, and we lost them in the feed yard. So driving this trait down over time with a genetic selection tool has been kind of our approach at Simplot. A little bit of background before I dig too far into the data set. Simplot's a vertically integrated producer. We have several commercial ranches spread across the Northwest. We've got a couple of feedlots. Our big one in Grandview, Idaho, and one up in Pasco, Washington. We're somewhere north of 200,000 head on feed. We also have a packing plant just up the road from Grandview, about 40 minutes, CS Beef Packers. So we're the research and development arm of Simplot Livestock, and we do research and genetic improvement across all of our purebred herds and throughout the supply chain. Wanted to give an example of how this trait hits us. This is an example of a group. This was a lot of Angus and Angus Hereford Cross single origin ranch heifers. These came off of our ZX ranch in Paisley, Oregon. We had 988 head received December of 2020. They were scheduled to ship the following August, the first week of August. This group had 32 mortalities total. 26 of those were heart failure deaths in the feedlot. So if you look at the timeline across the bottom there, we had a few we lost early on in the summer. Then as we got the last 2 weeks, 2 to 3 weeks before harvest, we lost a big bunch of those calves. Big, pretty animals ready to get on the truck, and they didn't make it on the truck. This is why this trait's so important to us and why we've invested a pretty big chunk of our research budget into finding a tool that works today. So starting out, we were tracking this trait in our feedlot in Grandview, and we started to decide that we wanted to phenotype some animals coming through the packing plant. So we adopted Dr. Holt and CSU's heart scoring guide, the 1 to 4 guide. We kind of think about it as two distinct buckets. We have normals, 1s and 2s. We have congestive heart failure cases in the 4 and 5 categories. So what we did is we send some trained technicians, myself and Dr. Raymond as well, send our guys into CS Beef, put them at the gut table with a laptop and a scanner, and in a morning they can score 400 to 500 hearts and be back before lunch as the table runs. So as soon as the heart comes out, we scan a carcass tag, we score the heart, and that data goes and ties back to our feed yard system. These are some pictures we've collected that kind of match that 1 to 5 scale. These are directly out of CS Beef. There's that 1 over there with, Dr. Holt describes the nice tight apex. It looks healthy. All the way over to a 5. We've seen this before. The heart looks like a deflated basketball almost laying on the table. It's completely lost all structure and tone. So the data set that we've collected. So to date, we've collected close to 79,000 heart scores, all out of CS Beef. These are all fat cattle that walk through the plant. So these all made it off the truck into the plant. These are the percentages that we've seen since 2020. The big picture here is Since 2020, about 4.3% of cattle that walk through the packing plant door are at a heart score 4 or 5. So they are in end-stage heart failure. One more stressor, one more weather event, those animals are going to become a feedlot dead. So it's kind of like tip of an iceberg. The iceberg is out there in the feedlot. You know, standing out there today, we have this population of cattle, and we've got to figure out how to reduce that population using genetics over time. So we took our population of phenotypes and we did some genotyping. Early on, we did some full genome sequencing with a company called GenCove. Today's data set, we have 11,000 contemporary grouped individuals with data captured. So they have the full data set from feedlot entry all the way to harvest, including the carcass data from CS beef. Those have been genotyped on the Neogen LD100K product. The data set today, it's got about 9,400 normal heart score 1s and 2s, 1,500 4s and 5s. We do see those 5s in our data set because we are so close to that packing plant, we can get those up there. So we're sitting about 13.7% case percentage in that population. With our work with GenCove, with the full genome sequencing, they did some work with us to look for markers of interest. We initially thought, you know, some of the work that Dr. Vanderlei has done, we initially thought there's a good chance this can be narrowed down to a couple of causative markers. These are the two markers that were identified in the UNL data set from US Mark. Those are the two causative markers. They didn't really have a peak that suggested those were true causals in this data set. The big takeaway we learned from this exercise was that the heritability is somewhere between 0.3 and 0.42. So this is a pretty moderately heritable trait. You know, it's in line with carcass data or carcass weight and gain. So there's an opportunity here for selection with this trait. Just some background on the population structure that we've phenotyped. So we've come at this as a true multi-breed approach. We phenotype large lots of cattle that come through the packing plant. So towards the right of this graph, this is a PCA of the genomic breed percentage. Towards the right of this graph, those are black-hided, primarily Angus-type cattle and crosses. On the left side, we're looking at probably more Charolais and Charolais dairy crosses. But the different colors highlight the diversity in this data set that we've got today. Dr. Holt mentioned this with PAP. You know, it is a problem with every breed. Those red dots are now showing the congestive heart failure cases. All the way through the dairy crosses, we see this trait pop up. There is a little bit of concentration, though, towards the black-hided side of this graph. It's kind of no secret in the industry that this is a problem that affects black-hided cattle, and this data set really kind of highlights that issue. So this is the categories on the screen now are classifications when we process cattle into the feed yard. So the gray bars are the black-hided cattle. We have our English cross. Those are our ranch-type cattle that are black-hided. Those are by far the biggest problem in the feed yard. Those are up over 5%, 4s and 5s. There's our Holstein beef on dairies. We call these primarily beef on dairy Angus-type cattle, but from our supply chain, we know there is some Limousin and some Simmental in those cattle. We just don't have the reference panel to identify those calves, so we kind of just assume they're Angus. The Holstein beef cattle, the Smokies, those are the Holstein beef Charolais. Those are not too big of an issue for us. And the Smokies, those are the ranch calves coming off the ranches. Those are a little bit higher. Again, those cattle, those Smokies are up to 50% Angus in their genetic background. GenCove did some additional work looking at what's the association with the different breed types in the population. So on the bottom, there's heart score 1, 2, 4, and 5. As you move on the y-axis, that is percent Angus. So 4s and 5s certainly have an elevated percent Angus in those cattle. There's a second look at that association. So as you move from 0 to 100% Angus, the risk of a calf dying from congestive heart failure goes up tremendously. It's a pretty strong association in that data set. We did look at the rest of the breeds in there. So Charolais has an inverse association with risk of heart failure. Hereford and Holstein are pretty flat, and then there's the Angus again in that graph. We also looked at feedlot performance. So that's a lot of numbers, so I'll kind of break it down to the big picture. Live weight at harvest, so as we move from a heart score 1 to 5, heart score 3s tend to be our heaviest animals. Same with carcass weight. So this kind of indicates to us that the fastest growing animals, the animals that are putting on the most weight, are at risk of becoming a 4 or 5. It's kind of bad news for our selection indexes given the direction that those point with carcass weight. And as you see, as you get to a 4 and a 5, those animals are beginning to drop off in performance. They're losing the ability to put on additional pounds of carcass in that last feeding window. Here's the first 120 days on gain in the feedlot. It's not really apparent in those cattle. There's maybe a slight dip there, but none of those differences are significant from a statistical standpoint. If you move to the last 80 to 120 days on feed, you can see those cattle drop off pretty significantly. They're beginning to enter end-stage heart failure and become those feedlot deads. We were a little surprised when we looked at the fat traits, back fat and marbling. We were expecting, given higher levels of fat, the data suggests that those animals would be more likely to be entering into hypoxia, but the data does not say that that's what's going on. There's a pretty flat association across those traits. None of those differences are significant from each other. So we also looked at heritabilities across all the carcass traits. Our data set today says we have a heritability of 0.34 for congestive heart failure. The rest of the carcass traits are pretty close to what we would observe in normal production setting. Genetic correlations. So this kind of follows the carcass data. Genetic correlation to carcass weight is close to 0.4. Gain and dry matter intake also have a moderately positive genetic correlation, and slightly negative for the fat traits. This to us raises some alarms because these are pretty well mirroring what we're doing in our selection index for terminal sire performance. So this is a problem that we're actively selecting for today. So if we continue down the road we're on using our selection index, drive up carcass weight, drive up performance, this suggests congestive heart failure is going to increase in frequency over time. So we took our data set and we've created an EPD out of the congestive heart failure data. So it's a 0-1. Normals are treated as zeros. Cases are treated as ones. Today, this data set has around 11,000 genotyped animals. When we do a five-fold cross-validation and compare the blinded to the EPD, we get a correlation of about 0.86. So this is telling us our EPD is working. We can predict pretty well what's going on. The other piece of this is that we've committed to continue phenotyping and genotyping animals. We're not stopping here. Over the next 5 years, we're going to add 5,000 genotypes and phenotypes per year to the model. These, in our world, these are considered small data sets, and we want them to be bigger and more accurate as we go through time. Just a quick plug, if you want to look at our data in more detail, we recently published a paper in Frontiers in Genetics. You can get in contact with us. We can send you a copy or go look it up. It shows all of our genetic analysis and our work there. We did this in collaboration with Jen Cove and Dr. Mike McNeil. It came out this summer. One more plug for Neogen. Our test is available through Neogen today for commercial cattlemen. They are developing that trait at the moment, getting it into their pipeline. It's not available today, but it'll be in their product line in the next few months. We also work directly with individual breeders. So if there's a breeder that wants to come to us and either submit DNA to us or they can get us genotypes, we can create the CPD, have it back to you within a week or so. Big thanks to the crew at Simplot. This is a lot of data collection, and all of these people have put in a lot of work to get that data in our hands. Also, reach out to us, reach out to Dr. Randall Raymond as well. We'd be happy to answer any questions and dig deeper.